Hi everyone, welcome to Rao's chemistry classes. So in this video, I am going to explain one of the important organic concept, that is electronic effects. So how electronic effects are arrived and how many types we will discuss very clearly. Actually for competitive examination purpose, this concept is very much important. Like NEET examination and JEE examination, most of the questions, most of the MCQs comes from this concept only. And students also feels somewhat difficulty. So that's the reason I am going to give as much as possible very smooth manner. So listen very properly, just look at the board. So electronic effects, and one more important point, this session to be English and Hindi. Yeah. So electronic meaning electrons. So because of shifting of electrons, effects are arrived. So total electronic effects kitna types? Permanent effect and a temporary effect. So permanent effect kaisa aate and temporary effect kaisa aate. So permanent effect without using any reagent. So but a temporary effect with using reagent. So reagent two types, electrophilic reagent, nucleophilic reagent. Reagent use किया तो ये effect आते, इसलिए temporary. So reagent use का जरूरत नहीं. Without using reagent also this effect is possible. That's the reason this is called permanent effect. So before getting to electronic effects, I would like to tell you one important point. As electrons basically three types: sigma electrons and pi electrons and lone pair electrons. All single bonds. Single bond is nothing but saturated compounds. Single bond is nothing but sigma electrons. Double bond and triple bond are called multiple bonds. Multiple bond meaning pi electrons. And one more type is there, that is lone pair. Lone pair is nothing but non-bonding electrons. Yeah. Just look at the board. Permanent effect, this is also called polarization effect. Temporary effect, it is also called polarizable effect. So permanent effect again classified into three types: inductive effect, resonance effect, it is also called mesomeric effect. Next, hyperconjugation, it is also called no bond resonance. Next, temporary effect, only one type is there, that is electromeric effect. So here main important thing is which electrons involved in inductive effect. अगर ऐसा क्वेश्चन आया तो ये बोलना, it involves only sigma electrons. Only sigma electrons बोले तो saturated compounds को ये सेट होते हैं ऐसा. Next, resonance, सबको मालूम है, resonance बोले तो delocalization of pi electrons. So resonance effect, it is also called mesomeric effect. So इसमें कौन से electrons involve होते हैं? Complete transfer of pi electrons or lone pair electrons to the adjacent atom. Next, hyperconjugation or no bond resonance. Delocalization of sigma electrons into an adjacent pi bond. Hyperconjugation में ऐसा होते. Next, electromeric में क्या होते? इसमें क्वेश्चन आया ऐसा, which electrons involved in electromeric effect? Answer is only pi electrons. Clear na? So next we will discuss clearly one by one. Hi. So in this video we will discuss inductive effect. How inductive effect arrived and how many types, we will discuss very clearly. So before getting to inductive effect, I would like to say one important point. First we need to discuss what are the electrons and what are the types of electrons. Generally everybody knows electron having negative charge and electrons are circulated around the nucleus. But when it comes to organic chemistry, we need to classify like this. Electrons two types. First one, bonding electrons, and second one, non-bonding electrons. So bonding electrons is nothing but sigma electrons and pi electrons. All single bond compounds are sigma electrons. Double bond or triple bond containing compounds are called pi bonds. Everybody knows non-bonding electrons is nothing but lone pairs. Is it clear, my dear students? Yeah. Next, very important point. So what is inductive effect? Which electrons are involved in inductive effect? This point is very much important. So only sigma electrons are involved in inductive effect. Only sigma electrons, that is nothing but saturated compound. So definition we can say like this. We can say like this. Displacement of sigma electrons along a saturated compound when an electron releasing group or electron withdrawing group is attached to end of the carbon chain. So displacement of sigma electrons along a saturated compound, this is nothing but inductive effect. How inductive effect is generated? Because of electronegativity difference between two atoms. Because of electronegativity difference, this effect is arised. Clear? Next, one more important point, inductive effect is the distance dependent effect. Distance increase हो गया तो inductive effect decrease होते. So ultimately here one important point is there, that is inductive effect is a distance dependent effect. Inductive effect can applicable up to 3 carbons. After 3 carbons, inductive effect negligible. Yeah. Okay students, just look at the board. What are the important characters of inductive effect? First point, inductive effect. Inductive effect. Inductive effect two types, minus I effect, plus I effect. What is minus I effect? When minus I effect is generated and when plus I effect is generated. Simple logic. Everybody knows alkyl groups. All alkyl groups act as electron releasing groups here. All alkyl groups act as electron releasing group here. Electron releasing group shows plus I effect. Bole to, when an electron releasing group is attached to end of the carbon chain, this effect is arrived. So this effect is due to electron releasing group. So what are the electron releasing group here? All alkyl groups. All alkyl groups. Yeah. Next, but what about minus I effect? So everybody knows functional groups. Functional group is nothing but actional group like alcohol, halogen, aldehyde, ketone, amine, etc. etc. All these are. Almost all functional groups act as electron withdrawing group. This is very much important point. Just look at the board. So minus I effect, it is due to electron withdrawing group. What are the examples? Almost all functional groups. Almost all functional groups act as minus I effect. So just look at the board, my dear students. Next, I am going with one example, that is this one. So here, this is the carbon chain. This is the carbon chain. So this is the end of the carbon. So end of the carbon chain, one group is there, that is chlorine. So here, chlorine and end carbon, these two very much important, these two deciding factor. So carbon, chlorine, out of two which is more electronegative? Chlorine. So more electronegative means it can able to withdraw the electrons. So here electrons shifted towards to chlorine side. Then chlorine gets partial negative charge and carbon gets partial positive charge. This is the first carbon, that's the reason this one shows maximum inductive effect. When comes to second one, the effect will be decreased. That's the reason this is denoted by like this, partial double plus. Next partial triple plus. Clear? So anyhow, here electrons are shifted towards chlorine side. That's the reason chlorine is nothing but electron withdrawing group. That is nothing but, this is the example of minus I effect. For better understanding purpose, I am going with one more example, that is like this. CH3, CH2, CH2, CH2. Let's take fluorine. Same logic. Fluorine is more electronegative. Then fluorine gets partial negative charge and this one plus, this one double plus, this one triple plus. But this one doesn't show inductive effect. Why? Because already I told you, inductive effect is the distance dependent effect. Distance dependent effect. It is only applicable to up to 3 carbons. Fourth carbon, inductive effect is negligible. Inductive effect is negligible. So anyhow, here also electrons shifted towards to fluorine side. Then this is the fluorine here act as electron withdrawing group, and this is also example of minus I effect. Is it clear, my dear students? Yeah. Next, electron releasing group. Already I told you, all alkyl groups, electron releasing groups. So here कभी कभी आपको question आते, which one act as strong plus I effect, which one shows maximum plus I effect, like that. Here carbons बढ़ गया तो inductive effect बढ़ते, plus I effect बढ़ते. So बोले तो 3 degree, 2 degree, 1 degree methyl. Out of all, which one shows maximum plus I effect? 3 degree, like this. CH3, CH3, CH3. This is 3 degree. So next, CH3, CH3, CH. This is the 2 degree. CH3, CH2. This is 1 degree. Everybody knows methyl. Methyl is nothing but like this, CH3. Clear na, students? Yeah. So this is inductive effect. Very much important. Just look at the board. So inductive effect, it is also called I effect. Because of shifting of sigma electrons, migration of sigma electrons, this effect would be arrived. So inductive effect mainly two types, plus I effect and minus I effect. And what is the difference between these two? We will discuss clearly. Yeah. Just look at the board, my dear students. Just look at the board. Inductive effect. It involves only sigma electrons. How to define inductive effect? Displacement of sigma electrons along a saturated carbon chain when an electron releasing group or electron withdrawing group is attached to end of the carbon chain. So displacement of sigma electrons along a saturated compound. So saturated compound bole to single bond containing compounds. Single bond containing compounds are called saturated compounds. Only saturated compounds influences inductive effect. Yeah. Next. So minus I effect, plus I effect. Minus I effect. It is arrived due to electron withdrawing group is attached to end of the carbon chain. Here electron releasing group attached to end of the carbon chain. So here one important point, all alkyl groups act as plus I effect, whereas remaining almost all functional group act as electron withdrawing group. So here order, here electron releasing group order. So plus I effect order, this is minus I effect order. This order is very much important for competitive purpose. So here one important point is there, positive charge, irrespective of charge, irrespective of positive charge, this is minus I effect. Irrespective of negative charge, if group contain positive charge, that is minus I effect. If group contain minus charge, that is plus I effect, reverse. So this is the order and this is the order. Generally examination में आपको questions ऐसा आते हैं, which one of the following group shows maximum plus I effect, which one of the following group shows maximum minus I effect. Suppose आपको एक बार examination में question ऐसा दिया, which one shows maximum minus I effect, which one shows maximum minus I effect. Andhra, CN, Bombay, NO2, Chennai, hydrogen, Delhi, phenyl. So the answer is Bombay. Reason, this is the order, NO2. Clear? Suppose एक बार examination में question आया, which one gives maximum plus I effect? 3 degree, 2 degree, 1 degree, methyl. Out of 4, which one gives maximum plus I effect? Answer is 3 degree. Clear? This is inductive effect. Hello everyone. So in this video we will discuss resonance effect. Resonance effect, it is also called mesomeric effect. It is one of the most important concept in organic chemistry. So resonance effect, it is also called mesomeric effect, and mesomeric effect two types, plus sum effect and minus sum effect. How to obtain plus sum effect and how to obtain minus sum effect, and which group act as plus sum effect and which group act as minus sum effect, we will discuss very clearly. Yeah, just look at the board. What is the concept? Resonance effect. So when plus sum effect is arrived and which group act as plus sum effect and which group act as minus sum effect, these 2 points very much important. So everybody knows electron releasing groups and electron withdrawing groups. Here how to identify which one act as plus sum group and which one act as minus sum group, I am going to give one important technique, that is those groups which donates electrons to aromatic system or conjugated system or double bonded compounds, that is called plus sum group. Those groups which withdraws electrons from aromatic system or conjugated system, that is minus sum group. Just look at the board. Plus sum, those groups which donates electrons to aromatic system or conjugated system. Next, minus M, which withdraws electrons from aromatic system or conjugated system. Just opposite. Which donates electrons, that is plus M group. Which withdraws electrons, that is minus M group. For example, I am going with this example. This is a aromatic compound, this is aromatic system, and ऊपर में ऐसा दिया NH2 दिया. This total compound is nothing but aniline. So here aniline shows which effect, plus M effect or minus M effect. This is very much important point. Next, here NH2 is the group. This group is the plus M group or minus M group. Simple reason. So here nitrogen contained lone pair. That indication nitrogen can donate electrons to system. It is a system. And it is a group. So here group donates electrons. ये डोनेट किया तो आपको ऐसा फॉर्म होते हैं, बॉन्ड तुम ऐसा शिफ्ट कर सकते हैं, लोन पेयर इधर आते बोले तो. सो हियर NH2 act as electron releasing group and it shows plus M effect. Next, one more example for this one. Like this. So here carbon not having lone pair, simple logic. Carbon not having any lone pair. That's the reason here scene is reverse. Here pi electron shifted towards to nitrogen side and carbon gets positive charge and positive charge withdraws electrons from this side. So here this is system and this is group. So here system to group, here group to system. This is the main important point. Electrons transferred group to system, here electrons transferred system to group. Reverse is nothing but minus M effect. So here Cn role, what is the role of Cn? Here Cn act as electron withdrawing group, means minus M effect. Okay, next, is it clear my dear students? ग्रुप अगर सिस्टम को इलेक्ट्रॉन्स दिया तो प्लस एम, अगर ग्रुप लिया तो सिस्टम से लिया तो दैट इज माइनस एम इफेक्ट. सो व्हाट आर द एग्जांपल्स ऑफ प्लस एम इफेक्ट? वेरी सिंपल लॉजिक. लोन पेयर कंटेनिंग compounds, if group contain lone pairs, that is important point, वो भी attached, ring attached atom को चेक करना पड़ेगा, aromatic ring attached carbon को चेक करना पड़ेगा, नहीं तो conjugated system चेक करना पड़ेगा. Yeah. So next, what about this one dear students? CH2 double bond CH NH2, double bond single bond lone pair, it is a conjugated system, it shows resonance. So here same logic, here lone pair is there, that's the reason it can donates, then we can shift the electrons like this. So here this is also act as plus M, this one act as plus M. Next one more example, CH2 double bond CH C double bond OH. So here C in reverse, this bond shifted to like this and this electron shifted to like this. Here CHO act as minus M. Is it clear dear students? Yeah. So anyhow, one important point, resonance effect. How resonance effect is arised? Because of delocalization of pi electrons. Because of delocalization of pi electrons. And mesomeric effect kitna types? Two types, plus M effect, minus M effect. Clear? Yeah. Just look at the board. Okay students, next concept, hyperconjugation. It is also called no bond resonance. No bond resonance. Yeah. So this is also one of the main important concept. Basically this concept explains stability. This concept mainly applicable for alkenes, free radicals, carbocations, etc. etc. But main these three very much important. So what hyperconjugation explains? Hyperconjugation explains stability. How hyperconjugation is arrived? Which electrons involved in hyperconjugation? It involves sigma electrons. We can say like this. Delocalization of sigma electrons into adjacent pi bond. Delocalization of sigma electrons into adjacent pi bond. And this concept requires one link, that is the heart of the point, that is sp3 sp2 link. This concept requires this link. This is the technique. And sp2 attached sp3. So this one act as alpha. So here you need to understand one important point. sp2 carbon means double bond carbon or carbocation or free radical. So sp2 means carbocation or free radical or double bond carbon. Double bond carbon. So sp3 means single bond carbon. Yeah, sp3 means single bond carbon. Okay students, first I am going with alkenes. Suppose last time एक बार examination में question ऐसा आया students, which one of the following compound shows hyperconjugation, which one of the following compound shows maximum hyperconjugation, which one of the following compound shows more hyperconjugated structures. You can get questions like this. First, so how to identify which compound shows hyperconjugation, I will discuss in a very smooth manner. Listen very properly. Just look at the board. First I am going with one example. My example is simple alkane. This is simple alkane, CH2 double bond CH2. Next one, propene, CH3 CH double bond CH2. Next one, like this. Okay. So total 3 compounds are there. Out of 3, which one does not show hyperconjugation? Answer is this one. This one does not show hyperconjugation. Why? Because double bond carbon is nothing but sp2 hybridization. Double bond carbon is nothing but sp2 hybridization. What I told you, my dear students, this concept requires this link. sp3 sp2 link is required. So here both are sp2 sp2. So that's the reason this one does not show hyperconjugation. When comes to this one, is it possible or not? Is it shows hyperconjugation or not? Yes. Why? Because double bond carbon is nothing but sp2 and single bond carbon is nothing but sp3. So our link is there, sp3 sp2 link is there, and not only link, it should be satisfy one more rule, that is alpha hydrogens. So this one act as alpha, single bond carbon, alpha. So at least alpha carbon contains one hydrogen, then only it shows hyperconjugation. So here how many hydrogens are there? Alpha carbon having 3 hydrogens. So here how many alpha hydrogens are there? 3 alpha hydrogens are there. So then it shows hyperconjugation or not? Yes, definitely yes. Next, what about this one? This one shows hyperconjugation or not? Yes. Why? Because this is sp2 carbon and this is sp3 carbon. So here sp3 sp2 link aya. So this one shows hyperconjugation. Why? Because sp3 carbon act as alpha having 2 hydrogens. ये भी check करना पड़ेगा. sp3 sp2 link is required, as well as sp3 carbon at least contains 1 hydrogen. That is called alpha hydrogen. That is also required. So ultimately 2 points are required. First one, sp3 sp2 link is required. Next, at least 1 alpha hydrogen. Yeah. So next, what about this one? This one shows hyperconjugation or not? This is benzene. No. Why? Because benzene contains 6 carbons and 6 carbon shows only one hybridization, that is sp2. So this one does not show hyperconjugation. Clear? Next, what about this one? CH3 CH double bond CH CH3. This is 2-butene. This is 2-butene. What about this one? CH3 CH2 CH double bond CH2. This is 1-butene. Examination में एक बार question आया. Out of 2, which one shows maximum hyperconjugated structures? Out of 2, which one is more stable? This is alkene. This is also alkene. ये दोनों में कौन सा stable? So already I told you hyperconjugation explains stability. So दोनों में कौन सा more stable? This is more stable. Why? Because here more alpha hydrogens are there. Increase the alpha hydrogens, increase the hyperconjugated structures. So let's check it. This is sp2 and this is sp3, means this is alpha. This is sp2 and this is sp3, means this is alpha. Here how many alpha hydrogens are there? 6 alpha hydrogens are there. But this is double bond carbon, there is no another carbon, leave it. this is double bond carbon, this is sp3 carbon, means this is alpha. Total here 2 alpha hydrogens are there. Here 6 alpha hydrogens and here 2 alpha hydrogens. How to find out hyperconjugated structures? There is a one formula, that is number of hyperconjugated structures equal to number of alpha hydrogens plus 1. This is the standard formula. So here 6 plus 1, total 7 hyperconjugated structures. Here 2 plus 1, total 3 hyperconjugated structures. Then increase the hyperconjugated structures, increase the stability. So out of two, which is more stable? Yes, this is more stable. Clear? Next, same scenario. When it comes to carbocations, same scenario. Yeah, just look at the board. Next, hyperconjugation for carbocations. Yeah, first point, this link is required. sp3 sp2 link is required. sp3 act as alpha. Okay na? So which link is required? sp3 sp2 link is required, and this one act as alpha, and alpha carbon at least contain one hydrogen. Yeah. Next, CH3 CH2 plus. This is the carbocation. This is primary carbocation. Why? Because this is carbocation. This carbon C plus here attached to only one link, one carbon. That is nothing but primary. Okay. Is it shows hyperconjugation or not? Yes. Why? Because the hybridization of any carbocation, whether it is primary or secondary or tertiary or methyl, whatever, carbocation, sp2 hybridization, this is fixed. So this is sp2. So next, single bond carbon, sp3. So what about our link? sp3 sp2, aya. So next, sp3 act as alpha. How many hydrogens? 3 alpha hydrogens. How many hyperconjugated structures? 3 plus 1, total 4 hyperconjugated structures. Yeah, possible or not hyperconjugation? Possible. Next, what about this one? CH3 CH3 plus. Before that, is it primary carbocation or secondary carbocation or tertiary carbocation? This is secondary carbocation. Why? Because this is carbon plus attached to 2 carbons. Yeah, this is 2 degree. This is sp3 alpha, this is also sp3 alpha. Total 6 alpha hydrogens are there, and total 7 hyperconjugated structures are there. Clear na, students? Yeah. This one also same scenario. Next, when it comes to free radical, same logic. Instead of carbocation, instead of positive charge, there is a radical. Okay. So this concept mainly explains stability. Examination mein ek bar question aisa aaya. Out of all, which one is more stable? Just look at the board. CH3 plus CH3 CH plus CH3 CH2 plus CH3 plus. So this is 3 degree carbocation, this is 2 degree carbocation, this is 1 degree carbocation, and this is methyl carbocation. Out of 4, which is more stable and which one contain maximum hyperconjugated structures? This one contain maximum hyperconjugated structures. So here total how many alpha hydrogens are there? Alpha, this is alpha. There is no alpha. So meaning 9 alpha hydrogens, 6 alpha hydrogens, 3 alpha hydrogens, 0 alpha hydrogens. Clear na? So this one shows more hyperconjugated structures. This is the stability. Is it clear, my dear students? Yeah. Okay, students. Next, last and final concept, electromeric effect. So electromeric effect. Electromeric effect is the temporary effect. So actually we have mainly 4 effects are there: inductive effect, mesomeric effect, hyperconjugation effect, electromeric effect. Out of 4, which is a temporary effect? This is the temporary effect, and this effect involves only pi electrons. This is very much important question. एक बार examination में question आया. Which effect involves only pi electrons? This effect involves only pi electrons, and this is the example of temporary effect. Yeah, temporary effect meaning here reagent is required. Reagent is required. Without reagent, this effect would not possible. With reagent, this effect is possible. So what is electromeric effect? Electromeric effect is arrived due to pi electrons. Electromeric effect kitna types? 2 types: plus E effect, minus E effect. Yeah, just look at the board. It involves only pi electrons. Next, electromeric effect mainly two types, plus E effect and minus E effect. So when plus E effect is arrived and when minus E effect is arrived. Yeah. So generally alkenes and alkynes generally shows plus E effect. This is beautiful point, a very important point. Keep in your mind. Generally alkenes and alkynes undergoes plus E effect. Generally cyanides and carbonyl compounds like aldehydes, ketones undergoes minus E effect. Just look at the board. Yeah. Next example. This is alkene and this is electrophile. This bond is shifted to like this and negative charge goes and attached to electrophile, then forms like this. Yeah. Suppose if you remove this reagent, again it comes to original position. That's the reason it is a temporary effect. So temporary effect means with reagent only it is possible, without reagent not possible. And next, suppose when you take unsymmetrical alkene react with HBr, what will happen? HBr means H plus Br minus. So this one follows Markovnikov rule. Everybody knows one important point. Unsymmetrical alkenes generally undergoes Markovnikov rule. What is Markovnikov rule? Negative part is attached to unsaturated carbon which carries less number of hydrogens. Negative carbon is attached to unsaturated carbon which carries less number of hydrogens. Yeah. Here what is the electrophile? H plus. What will happen here? This bond is 100% shifted towards to right side only. Yeah. Next here positive charge and here negative charge. Initially electrophile goes and attach. That's the reason this is electromeric. Positive electromeric. Yeah. That is important. Initially it forms like this, CH3 CH, CH2 minus H plus आया तो CH3, here positive charge. Next Br minus goes and attached to this carbocation. Then answer is like this. Anyhow, here initially H plus goes and attach. That's the reason this is plus E effect. Next, what about minus E effect? Suppose if I take carbonyl compound, then a nucleophile. This is also reagent. This one shifted like this. This one comes and attached like this. Then forms like this. Clear? Yeah. So these are electronic effects, dear students. Okay. Thanks for listening this class, and if you get any doubt you just message me, and each and every student please subscribe my channel and hit the bell button to get further notification. Yeah. Bye for now. See you again.